Hello friends, today we'll see preparation of phenols. Let's see the first preparation. First is from chlorobenzene by Dawes process. In this chlorobenzene is treated with NaOH and it is converted into sodium phenoxide, and that again with hydronium ion gets converted into phenol. It is a nucleophilic substitution reaction and benzene is already electron rich. So nucleophile can't attack easily on benzene because benzene is electron rich and nucleophile is also electron rich. Therefore, very high temperature and pressure are required for this reaction. And this NaOH splits like this: H plus and ONA minus, and this H plus goes with Cl to form HCl, and this ONA comes here, O minus Na plus, and then and when it is treated with hydronium ion, so H plus from hydronium ion combines with O minus to form OH, and Na plus goes out. So that's the product phenol. So chlorobenzene is fused with NaOH or at high temperature and pressure 623 Kelvin and 300 atmospheric pressure is there, followed by treatment with dilute HCl to obtain phenol. So this process is known as Dawes process, and it requires very high temperature and pressure because it is nucleophilic substitution reaction on benzene ring. Now let's see the next one. Next is from cumene. Cumene is also known as isopropyl benzene, and you can see the structure. Just draw isopropyl instead of second position. You can draw C6H5 instead of that ring. So isopropyl benzene is known as cumene when it is oxidized in the presence of cobalt naphthenate catalyst at 423 Kelvin. Insertion of oxygen happens and we'll get cumene hydroperoxide as the product, and when that cumene hydroperoxide is treated with dilute HCl, we'll get phenol and acetone as byproduct. So this is commercial method for preparation of phenol. Cumene, also known as isopropyl benzene, on air oxidation in presence of cobalt naphthenate gives cumene hydroperoxide, which on decomposition with dilute HCl gives phenol and acetone as byproduct. So here this part gets converted into acetone rearrangement, and this OH comes to ring and phenol is formed. Then let's see the next preparation. Next is by benzene sulfonic acid. So benzene sulfonic acid first treated with sodium hydroxide. So H is replaced by sodium. Here sodium hydroxide splits like Na plus and OH minus. OH minus treats with H plus to form water as the byproduct. No need to write what it is, just for understanding. And this Na plus comes in place of hydrogen. So SO3H is written as SO3Na. And that acid again treated with sodium hydroxide, NaOH. So this time this SO3Na goes out with H and ONA comes it at 573 Kelvin. And last step is same, that with dilute HCl, that ONA, sodium phenoxide, gets converted into phenol. Sodium phenoxide is like ether only, therefore phenoxide is written. So that's how we can first convert benzene sulfonic acid with the help of NaOH to sodium benzene sulfonate. That sodium benzene sulfonate with NaOH at 573 Kelvin converts into sodium phenoxide, and ultimately with dilute HCl, sodium phenoxide gets converted into phenol. Okay, So again this is a nucleophilic substitution reaction, therefore high temperature is required. Benzene sulfonic acid on neutralization by NaOH gives sodium benzene sulfonate, which on fusion with solid NaOH at 573 Kelvin gives sodium phenoxide, and that formation of sodium phenoxide is followed by reaction with dilute HCl and phenol. So that's all. And now let's see the last one, that is the preparation of phenol from aniline. Aniline NH2 is bad leaving group. So this first we have to convert that bad leaving NH2 into good leaving group, and then we can easily treat good leaving group to phenol. So see, formula of aniline is C6H5NH2, or we can write benzene ring, on that write down NH2, and when that treated with HNO2, HNO2 is formed by NaNO2 plus HCl at 273 Kelvin. 0 to 5 degree temperature maintained is required for this reaction, because this reaction is highly exothermic. So when nitrous acid HNO2 is prepared, when NaNO2 is treated with HCl at very low temperature, and that HNO2 forms benzene diazonium chloride with aniline, and benzene diazonium chloride is good leaving group. So bad leaving group NH2 gets converted into good leaving group N2 plus Cl minus because of HNO2, and then it is good leaving group. So just by addition of water, so water gets splits into H plus and OH minus, and this OH minus comes to comes to benzene ring and form phenol, and H plus goes with the Cl minus to form HCl, and nitrogen gas goes out. So N2 plus Cl is good leaving group, it easily goes out just by warming that intermediate with water, will get phenol. N2 plus nitrogen gas goes out, and HCl is the byproduct. H from water and Cl is already there, and that's how phenol is formed. So from aniline, first convert that bad leaving group into good leaving by nitrous acid, then good leaving group just treat that with water to form phenol, nitrogen gas and HCl are byproducts. Okay, so this reaction is also known as diazotization reaction. Aniline is treated with nitrous acid NaNO2 plus HCl at low temperature to obtain benzene diazonium chloride, which on hydrolysis gives phenol. So that's all. We saw all four reactions for preparation of phenol. First is Dow process, then from cumin, then benzene sulfonic acid, and last is from aniline. That's all. Thanks for watching the video.